Here we have example 10. Suppose the amount of oil pumped from one of the canyon wells in Whittier, California, decreases at a continuous rate of 10% per year. So we can come up with an equation for that. Well, I guess I need a pen first. Let's say we start at 100%. We're going to lose 10% each year. So we're only going to be at 90% of what we were before. We need the output to fall to 1/5 of that. So 1/5 of 100 would be 20. Or we could solve it like that. 1/5 equals 0.9 to the t ln of 1/5 equals t times ln of 0.9. So t equals ln of 1/5 or ln of 0.9 years. Now remember these are logs and we could write them in a couple different ways. It could be ln of 1 minus ln of 5 on the top, or just negative ln of 5 on the bottom. It could be ln of 9 minus ln of 10. There's a lot of ways that we could divide those, but we're not. All right. Fruit flies, that's pretty exciting, right? We're going to find the equation here. It grows in proportion to the number of fruit flies. That's good, because then we can say this. That means we're working with an equation in this form. All right, so we know that we can write an equation if on the second day there were 100 and on the fourth day there were 300. Whoops. That looks awful. Let's try to rewrite that. Okay, on the second day there were 100. On the fourth day there were 300. All right, so we can write an equation for both of them. Let's see. So we have 100 equals c e to the 2k, or we have 300 equals c e to the 4k. Now we have systems of equations. We could divide the equations. All right, so I'm going to divide equation 2 by equation 1. 300 divided by 100 is 3. C divided by C, that disappears. And then e to the 4k over e to the 2k equals e to the 2k. All right, now that's something easy to solve. And 2k ln e, so ln 3 over 2 equals k, which is really helpful here. All right, so now if we write it, let's go back to our original equation, c e to the 2, why did I do that? Not the original, actually. Let's go back to this one. Since we have 2k times 1/2 ln 3, because k is 1/2 ln 3, we end up with ln 3. I used the 2 already. All right, and then e to the ln of 3 is just 3. So this helps us figure out our c, or our original amount. So we ended up with 33 1/3 fruit flies in the original population. So we had 33 and then a couple little pieces. So there you go. Okay, last example, example 12. We're going to finish strong here. This was on the 2012 AP exam. Oops. All right, the rate at which a baby bird gains weight. So you got to think of a nice little baby bird as you're doing this problem. The rate that it gains weight is proportional to the difference in weight. So that's good, because then we know we're working with that kind of equation. So let's just read, is it gaining weight faster? So we know we're talking about rates. All right, so let's see, when b equals 40, our rate db over dt equals 1/5 of 100 minus 40. So 60 over 5 equals 12. And what are grams? And what's T in days? Okay. And then when B equals 70, dB over dt equals 1/5 of 100 minus 70. 30 divided by 5 would be 6 grams per day. So is the bird gaining weight faster when it weighs 40 grams or when it weighs 70? Let's answer that. This kind of problem you'd want to answer with a sentence. The bird is gaining weight faster when it weighs 40 grams because 12 grams a day is more than 6 grams per day. Okay, that would be a good way to explain that. Find the second derivative in terms of b. All right, so let me rewrite my first derivative down. We're going to take the derivative. We're going to show that we're going to take the derivative. Oops. Okay, so we get second derivative there. So we'd have and the derivative of the inside is negative dB dt. All right, but we have dB dt, so we have to fill that in. And that was negative this. All right, let's clean that up. I have too many parentheses there. So that'd be negative 1/25, and then we have 100 minus b. Okay, explain why the graph of b cannot resemble the following. All right, so what do you notice about this function? Well, we know that the weight of the bird should be greater than 0, right? And if b is less than 100, then so say like 90, 70, 60, the function should be concave down, like a frown. But that doesn't match this graph. This graph is concave up, like a cup. So that would be a way to explain that. All right, and then the really fun part, we're going to separate the variables. dBdt equals 1/5 times 100, and then use it to solve it for a particular solution. So first we need to separate the variables. Okay, this looks like it could be hard or it can be really easy. It all depends how much you remember. After we separate the variables, we're going to integrate. Here's where you can either do really well or really bad. So it's almost ln of this. But if we took the derivative of that, we get 1 over 100 minus b times negative 1. So we have to fix that with the negative. And then equals 1/5 t plus c. All right, let's move the negative to the other side. Plus c. Notice I didn't make the c negative because it's a constant. It doesn't matter. All right, if we exponentiate it, we get 100 minus b equals e to the negative 1/5 t plus c. Remember, if we have that plus c in the exponent, we can move it to the front. 100 minus b equals c e to the negative 1/5 t. All right, and then just rearranging that, we get 100 minus c e to the negative 1/5 t equals b. There's our general solution. And lastly, we just have to plug in that point at the point 0, 20. We put 0 in for t, 20 for b. So 100 minus e to the 0 is 1, so 100 minus c equals 20. C equals 80. So our particular solution would be b of t equals 100 minus 80 e to the negative 1/5 t. All right, there's a couple things I just want to point out. if you separated the variables, probably you got a point. Oh, that's not where I did that, but there. And then these are usually worth 5 or 6 points. If you integrated correctly, you probably got a point or two. If you solved for B, if you use the initial condition, I mean, this is probably like 5 or maybe even 6 points on a free response question. So these are so easy. If you get these, you want to go, yes, yes, I've got it, because you know that this is worth a huge chunk of points, and all you have to remember to start is to separate the variables. Okay, so that's the big idea of this whole section.